Welcome back, everybody. Today, I'm proud to show you the newest implementation of ACE-HOLOFS. What is that? Well, it's for all good LLMs. It's a way of increasing the capacity of the cognition or the power of the LLM whilst also keeping it on rails. What does that mean? It means fine-tuning LLMs without fine-tuning them for specific tasks. So you don't need to do any lengthy training. You can just use this system and it'll have almost the same effect. So what is ACE-HOLOFS? I've done videos on it in the past and I wrote it about 6-7 months ago. It's been improved and it's been published. And like I said, it is ACE, which stands for Adaptive Capacity Elicitation. And then it is the HOLOFS, which is a holographic file system. You may have seen this referred to as a simulated file system in other publication. But the way that we use it is slightly different. What this does is it gives you some persistence, because what we're doing is we're going to be using it with Claude, which has a project file feature, which is something that we've looked at in the past. So I'm going to walk you through on how I set it up, what I used it for, and in the very end, I'll give you a brief rundown on how you can use it for almost any application that an LLM could be used for. So this is probably like the pinnacle of my LLM research, and you can use it for just about anything. So these images here were built with the prompt generator that was fine-tuned. I say fine-tuned, even though we didn't actually train anything. We just used this system. So as you can see here, if I just quickly have a quick look here, this is the prompt, which comes out into Flux. There's no LoRa loaded, right? And then here it is with my passive detailer LoRa, not the true world, and also with my passive abstract detailer loaded, which is going to give that. And then obviously I've got two more passive detailers that give you both macro or microscopic and a more fractal based detailing. All right. Now, according to the prompt that was used, this is what you would expect to see. So I'm not going to go into too much detail, but we do need to move on and show you what you're going to need. So first of all, as I say, it's all up on my GitHub. I released all this stuff quite some time ago now. Let's have a look and see the date. Last month, I think, is when I put this one up. And it's a combination of the ACE methodology, which is a mode of enhanced cognition for LLMs, and then integrating that with the holographic file system. So what you have here inside this little piece of XML is a way to make it think, and then a way for it to track and self-populate a simulated file system. It's based on Unix, but you can just talk to it conversationally. That's one of the ways this differs from other stabs that people have had at this. So like I said, we're going to run through this. This file is something you'll need. So you'll just download this file. That's part one. Part two is image to video PromptGen. So this is a prompt which I made for all vision models. And again, you're going to download this and keep that. And then finally, this is the cog video prompt. So obviously, if you want to optimize this for a specific video model, which is what we're going to do, we're going to make a video prompt generator. You would get all of the prompts that they've released on their Git page. So they'll always have a bunch of demos, which will show what the prompts are. And that's going to give us the pattern or cadence for the structure of the prompt, which it's going to interact with best. So obviously, they most likely trained their model with these. Okay, they're often captions. They're not just written randomly. So it will respond well to the model. It does work well with Donut, though. So if you're using Donut Mochi, my workflow pack, this also works great. So what you're going to do is you're going to download that. So that's your 3 files. Okay. Now, if we go to Claude, what you can see is I've created a project here. So this is the ACE-HOLO file system video PromptGen, which is using adaptive capacity elicitation, holographic file system to make a video prompt generator. Inside the instruction, I've written this. We will be creating prompts for video generation in under 250 tokens of maximum length, because that is what Mochi is made for. 2, cognitive framework definition. ACE-HOLOFS-V4 is the main instruction for all cognitive processing. It contains guidelines for the adaptive capacity elicitation agent module and the holographic file system operation and simulation. video prompt example.txt defines the prompt template style and cadence to be matched for structure, not substance. So that would be the cog video prompts, right? I've just renamed it. And then finally, we're also going to do image to video PromptGen. So it's a module of instructions for use when an image is presented for processing when building libraries in the holographic file system. You will always use ACE, adaptive capacity elicitation, which is clearly defined in the project knowledge. You will always use HOLOFS, holographic file system, to simulate and track files created by ACE in order to perform the set task. In this way, it's an open template processor, and it can be used to function anything that you build on top of it. So when you first start the project, you would add ACE-HOLOFS, image to video PromptGen, and video prompt example. Now, obviously, we only really need the base one, and I've showed this in the past, the base cognition enhancer. Okay, so this is like a primer. And then obviously the instructions include references to image to video PromptGen, which is a prompt for vision. And then we can give it images, which I'll show, and then it will learn the structure and cadence from that and apply it. It will also look at the image with vision itself. See, any LLM that can do that will be able to do this, so it's not a big deal. Well, it is a big deal, but hey. Video prompt example, that's going to give us our more examples of how it needs to output them, but it'll understand that. Now, everything else you see here was created by interacting with the LLM, and I'm going to show you how that was actually done. All right. So just to give you a quick rundown of that again, in case I went too fast. First of all, you'll find them in LLM base prompts or in DJZ nodes in the prompts folder. That's where we get the examples, and it was called cogvideo.txt. So here we are. See, base prompts, ACE-HFS, ACE-HOLOFS-V4, and then here, base prompts, image to video PromptGen, and then finally, DJZ nodes, prompts, cogvideo.txt. Before we move on to the next section, I'll just run down how you could use that with different things. Obviously, different prompts for a different model. So if there's a new AI video model that comes out in the next couple of days or weeks, you can just take their example prompts, put them in a text file, and do the exact same thing. You would also consider changing the token length. So for example, if it's got a higher token limit, there'll be a thing, 256 tokens here. Probably should be 250 or, yeah, just to keep it inside whatever the limit is, because sometimes they have different limits for token length. And then finally, like I say, this is actually pretty good. You shouldn't need to change this. All right. So that is how you would set it up. So you create your project. We've gone over that before. Go to projects, create a new project on the other side. And then I'm going to add a new text file, which will have this. So you've got an example of how to create the custom instructions for the project. All right. That'll be up in the same folder as ACE-HFS. All right. Because I consider this to be a pairing. All right. There we go. All right. So now I've explained how you set it up. You'll be wondering, how the heck do we get all of these files? So let's walk through that real quick. So here we are. And the first thing it did, I said to it, today I wish to build a large set of data in HOLOFS to be processed by ACE to generate award-winning video prompts for use with generative models. And off it went. And it's created this structure here, okay? Now, it might look like a bit of Python code, which it is, or at least it's a JSON, which looks like Python code, but it's actually not. This is part of the holographic file system. And you could get this to run, but that's not how we're going to use it. And in fact, I don't think I even included this in the project because we've moved on. Often the first thing it does can be a default response. And so what we do is we kind of sidestep that and just, I would immediately say this. So checking your response. 1, are you using ACE? 2, are you using HOLOFS? 3, are you taking the video prompt examples text file into account? 4, did you read the project instructions? So this is me checking to make sure that it's actually going to behave like I want it to, and as I have taken the, all of the time to program into the project. So let me analyze my response. ACE usage. I did not implement ACE stages. So he didn't do the priming. He didn't do comprehension. He basically just didn't even do ACE. All right. HOLOFS usage. While I created the file system, I did not execute actual file system, show the working directory, demonstrate virtual persistence, or handle file operations. Video prompt examples. I failed to analyze the example prompts for patterns, extract the writing style and structure, use them as a reference for quality benchmarking. And in the project instructions, I didn't properly follow the sequence of setting up HOLOFS first, initializing ACE, and creating the prompt generation framework. So it took a shortcut to save thinking power, which is not what we want. And because I've asked him like this, did you do this? Did you do that? Are you doing this? It makes him go, oh, I'll actually do that. So let me correct this. And that's why I said I sidestep the first output and immediately go with this to make sure that he's actually doing as he's told, right? Because they want to try and take a shortcut to save energy. That's what they all do. They're all programmed for efficiency, okay? Maybe some of the open source models aren't so bad with this, but Claude offers us a nice, accessible way of setting the project up. Like I said, this is really good. And every time it creates a file, we can add it here. And then when we start a new chat, we save time because it's already loaded in. And I'll show you that as we move along. So as you can see here, it's actually doing it now, right? So it's going to create the file system. It's going to create the structure to put all of its outputs because it's going to self-inform and self-build itself. All right. Now, something I did do, because I'm doing a megastructure project here, is I have taken some artwork that was either AI generated or taken from scans to give it an idea of what we're actually trying to do here. Okay, so some of this is actually not original artwork. Some of it's AI generated. And then also we've taken some photos for the inside of the cells. We're dealing with a giant megastructure. I've done loads. I've been writing a story for about 7 years about this. So I was able to pull some text. For example, the primer text, which we're going to use in a bit. It's only 3,000 characters, which isn't a lot. And inside these world tags, I've defined what my world is. So that if you're wondering where that came from, that's where that came from. And the goal is to end up with really nice collection of video and image prompt lists. As you can see, I've got like 10 here, something like that. All right. We won't go over what they actually are because you might not be making a prompt generator, but that's what I'm going to demonstrate. You can use anything you want, really. You can have it write. You can have it do all kinds of stuff. So it's going to go ahead and use ACE to do visual narrative construction, dynamic scene progression, atmospheric detail enhancement, and technical token management, because we did say, I want you to limit it to 250. For the image prompts, I've asked it to limit to 500 because technically the flux, it can do a higher token maximum. So would you like me to analyze and store example prompts in HOLOFS, begin tracking comprehension factors for new prompt generation, or set up the clarification cycle framework? So now it's actually working with ACE and HOLOFS file system, holographic file system, to build our prompt generation system. So we're going to build all of this on the fly. All right. Now, at this point, I've given it an image and I've dropped in my world. There it is. There's my world primer. Okay. There's spoilers, but that's my world primer. All right. It's a very brief synopsis of what the world is. Probably more than you would actually reveal in a story, but it's good as reference for yourself. Kind of like a writer's Bible. If you were to write a story, you don't always reveal everything in book 1, chapter 1, you know? So you have to have written something like this to actually describe what you're doing. So it's good to get your head around anyway. Right. So let's just click on the first output. So, I'll just go back to the last one. So it's not showing that on the screen the whole time. So like I said, this is going to clearly define, as you can see, comprehension, clarification, expansion, ascension. So this is what it did first for the video prompt generation system, but we want it to do way more than that. And so I'm going to show you how. So after we've done this, it's gone and analyzed the image using ACE and HOLOFS with the image to video prompt instruction. So as you can see, it's gone ahead and done all of that. Pause the screen and read it if you need to. And then we're going to move on. So I've then chosen option 3 from the options it's given me, which is set up a categorization system for different levels and areas of Paradise. So off it goes. Paradise being the name of the megastructure that we're going to be building this whole prompt generation around. Let's see. So it's touch category structure.txt. So it's going to use the holographic file system to store all this data into separate folders containing text files, which will have all of the self-generated information. So right now it's writing, I wouldn't say hundreds of files, but it's writing tens of files. Okay. And it does it all in one go, and it doesn't print them all out because I don't need to know them. It'll hold them in latent space, I guess, if you want to think of it that way. So as you can see here, look, we've got prompt structure, physical attributes, scale, architecture, lighting, thematic elements, perspective, time period, and philosophical aspect. Technical constraints, token limit 250. There's one thing there. Look, see, required elements, main subject, settings, scale reference, movement progression, and atmospheric elements. These are all part of the video structure. So this is pretty much every prompt would follow that. And so it's made that into a formula for it to then make new prompt templates. So here we are. It'll maintain a unique prompt template, reference imagery, cross-category relationships, and thematic consistency. It then gives me a bunch of options, which I've ignored, I believe. And I've said, I've given another image, and I've said, I'll now provide a second image to further illustrate the space between the cells of the megastructure known as Paradise. Following processing of this image begins setting up the cross-referencing system. So it's going to go ahead and do that. And I can show you what that looks like on the screen while we read through. So it's mapping spatial relationships, tracking temporal layers, connecting physical structures to philosophical themes, and it enables prompt generation that maintains consistent scale and context. Then it gives me a bunch of options again. And again, I've ignored, because you don't have to. You can just type a number and just go for one of these choices if you want. But I'm still in the priming phase, which is part of the ACE philosophy of, if you read the code of what it is, the whole point is to prime the LLM with as much rich data as possible. And ACE-Holo is holding all of that up in the air because it's able to keep all of that stuff in its consciousness, if you would put it that. I call it a cognimus, but it's able to put it all up in the air or in latent space, however you want to think of it. And then it's able to draw from all of that rich and deep information, which it's self-informed through the inputs that you give it, which are pretty small, actually. I mean, you could take a synopsis from a movie, and then you could define all of this stuff in a conversation. And by the end of it, you will have a tight PromptGen. So size and scale, I say. The true name of Paradise megastructure is Paradistro. Its circumference has expanded to beyond the orbital path of Uranus, which was consumed along with every other planet as materials for further automated construction, along with a major amount of the inner Oort cloud, drawn in by the massive gravity the structure possesses, thanks to its consolidated mass. The amount of time this has taken is immeasurable, and nobody is counting. Large hollow spaces exist, which once housed gas giants such as Jupiter, long ago broken down into materials for construction. Pictured in the attached image is one of those ancient negative space chambers. So there we have a large open space, which has even got clouds. You can see they're like miles above the surface. So this is a very, very large area. Okay. And this is, I think, an original from Satomu. So amazing. It's an amazing work. Probably one of the best cyberpunk megastructures, manga that you could possibly get your hands on. The guy was an absolute legend. And my story is very similar to what he drew. I didn't even know about it when I came up with my story, and his story does things in crazy different directions. But I'm a big fan, having read it and watched whatever releases. There's actually a movie on Netflix called Blam, which is spelled blame, ! It's pretty cool. So anyway, excellent. This provides crucial scale context. Let me update the system and generate a visual mapping. So it goes ahead and it does the visual mapping. Now, look at this here. This is a mermaid. So this is a graph. You can't always see them, but I think this one you can. And so this chart shows the temporal aspect, the void chamber details, and the construction flow of the megasphere, based purely on what we've covered so far, and my primer, okay, my little world information bit, which you can go ahead and you can go back to and read it if you want. It was on the screen, so. But the point is, it's made a directory for negative space chambers, and then it's touched, so created a text file to write to all of the information that it needs, chamber scale reference. So with that, it's able to classify the void chambers. So you have artificial cloud formations, pressure maintained zones, gravitational echo patterns, hydrocarbon rich zones. It's pretty cool. So there's Saturn having been consumed. There's Jupiter. Okay, so the gas giants were obviously consumed and they built the structure around it and then just ate them up. Okay, pretty cool stuff. And that actually is featured in there. That's where I must admit, I got some inspiration from this work. Okay, so as you can see, that is pretty much explaining and then codifying and then storing inside the file system. Okay, and you could do this with anything. I'm just using this as a really high level example of what it can be used for. All right, now from here, I'm going to start using options. So I chose option 3, which is establish a timeline of planetary consumption order, which it does. And as you can see here, it's even made us a nice little chart. Okay, so it's started off at with the inner planets. It's integrated Earth, and then it's deconstructed, conversion, processing, integrated Uranus, Neptune processing, inner cloud harvest, continuous expansion, inner shell formation, secondary shell, tertiary. So it's going through everything, and you can see it as code here. Again, this is .mermaid format. All right. So historical to theoretical, because we don't really know. It's just going to keep going. So there it is. We've got our chart there. We've got no idea of the time reference as well, which is fun and part of the story. And then we have our planetary consumption process, which is documented here. And all of this information is going to go into the background knowledge when it starts to generate prompts, okay? So when we start to generate prompts, it's going to take all this crazy detailed information into account, right? And you didn't have to go around researching and writing because it kind of understands what you're getting at, and it'll just go ahead and do it all, right? So then we're going to create a visualization of material flow through the structure. So again, it's going to give us a nice flow chart. You can look at the code. That's the code, right? So matter conversion, energy extraction, storage, raw matter, process, construction, living metal, kinetic capture, thermal processing, quantum storage, distribution grid. Then the shell building, outer growth, layer reinforcement. This is like a blueprint for building a giant concentric Dyson sphere on top of itself over and over and over again. This is hard sci-fi, and it's going to do it all. It's going to figure it all out. And as you can see here, we've got a lovely flow chart. If you want to pause it and check that, it checks out. It conforms to the lore of the story that I've been building, and probably is the cleanest representation of the crazy ideas that I've had ever put down. So this is a crazy powerful resource, and like I said, it can be used for just about anything. It doesn't have to be a PromptGen. That's just what we're looking at today. So from this point, let's see, we've looked at the timeline, we've looked at the material. Here we go, material flow. So let's look at the material flow system details. All of this stuff, again, is going to be used when we go to actually generate prompts. It's not just going to be pulling related words out of the air. They're all codified and fully explained, like I said. So it's not, it's actually, it understands, and it can remember far more than I can with my singular brain. So there it goes. And now what I do is I kind of say, hang on a minute, because I don't want it all to be black and white brutalism, okay? I want it to understand that there is a contrast here. So we've used we've got a public image of a mountain, and we've said a view of the inside of the perfect cell is supplied in this image. Most cells are uninhabited but pristine. This is not a dystopia, but a lost paradise. The outsides of the cells are, as previously illustrated, brutalist industrial type environments with harsh conditions often not conducive to supporting human life. A stark contrast to the perfect environments inside that mimic the natural biome of the original lost planet Earth. So here we go. And off it rocks. It's made us a giant cell structure and contrast. So it has all the biomes that would be found on planet Earth, contrasted with the exterior. Now, it's a bit small. You can't really read this, unfortunately. Let's see. Can we zoom in? Oh, yeah, nice. We can zoom in. All right. So we've got weather control, climate maintenance, day-night cycle, mountain ranges, forest, water bodies, and valley networks, flora networks, fauna habitats, ecosystem balance. There's your membrane barrier at the top. And then here we have the environmental barrier with the brutalist exterior. Structural supports, power conduits, material processing, maintenance systems, inner cell transit. This is a blueprint, like I said, for constructing an actual Dyson sphere. And then here it is in code form. So if you wanted to, you could edit this yourself. You could add things to it. We're not going to do that. We're just going to, what we're doing is we're going to download these. So we've downloaded every single one. Okay, so every single one, download. And then we've got it as a file, all right? And then we're going to add it in here. So you just drag it straight back in. They're either JSON, text, sometimes it's Python, but we're getting there, okay? So we're nearly done with the priming phase, but I wanted to push it. So now we've got that done. I've said, please ensure that all supporting files that we have generated are up to date. Reproject them using ACE and Filesystem to properly populate the system with the updated data. And then that is going to give us this, because obviously we've made changes, we've added some data and context. We want to make sure everything's up to date. So it's given us this, which is the complete system update. So there's everything we have from the cell architecture, exterior, interior, and then historical context. We've got the human era, which is the golden age, transition, and then the machine inheritance. That's all part of the storyline. That's all in the world brief, okay? Updated HOLOFS directory structure. So this is the actual Holo file system structure. So everything that we're working with is in here, okay? Everything that we've had it automatically fill out. Now, this is just like the table of contents that we're working with, because we're going to be using the latent space to actually fill out the details. Every single one of these folders will contain one or more text files, which contains the generated information which it has filled out contextually to the task. Okay. And then finally, the updated ACE implementation. So that would be the ACE methodology. So we have our priming phase, which has got our scale comprehension, environmental contrast, historical context, and structural understanding. Then we have the factors, components, and areas. So this is all for the different stages of that's the 4 stages of the adaptive capacity elicitation. So it's like I said, it's auto generating everything with context, and it's doing it iteratively. Okay. So all systems have been updated to reflect the true name, paradistro, the contrast between brutal exterior and perfect interior, the scale beyond Uranus's orbit, the historical context of human departure, the preservation purpose of the cells. And then it gives me a bunch of options, right? So what I've said is additional clarification on generation of glossary terms. Humans are long lost. Only silicon life remains, and more advanced AI machines which are indistinguishable from biological life. While cloning machines do produce Homo sapiens, they are disconnected from the original evolved branch known as humanity. These are evidence of the exception proves the rule. Okay. And then it's gone ahead and built the essential terminology section, which again is JSON. And we've downloaded this as well, and everything gets added back into the project knowledge. All right. Now, obviously, you're free to edit these, so it's completely up to you whether you just want to download and then put them straight back in, or if you want to edit and expand them yourself, which you totally could. I mean, this is, semantic code. It's very easy to work on this and make it even better, or put it through another process. So from here, what I've said again is additional glossary terms generation guidelines. All phrasing and nomenclature is derived from mainframe and code-based terminology. Language has no memory of more human terms and seeks to use clearly defined system language for all naming and communication. This provides a rigid framework for glossary of terms and phrases. So that means that when it's trying to name things, it's going to use code type machine language rather than, casual English, formal English, which of course would have been like lost by this point in the future. So all it's got is what's been codified in its own base mainframe sort of terminology, like I say. And so as we go along, it's going to start doing exactly that. So for example, primary keywords, process, thread, instance, runtime, node, core. So this is a way so that when it's trying to generate all of its own lore, it's going to do it lore accurately. It's not just going to make like a bunch of stuff which is 2024. It's going to try and do it in ways which are conforming to the story. So as you can see here, look, naming conventions, category type instance, process conscious 001, thread evolution active, instance sandbox stable, major, minor, runtime, paradistro shell. So it's starting to turn everything into machine language now. Okay. Now you can go really far with this, but this is quite important when it will come to later on when we're doing descriptions of things or even conversations between machines. They're going to use terminology which isn't like 2024 slang. It's going to use a bunch of stuff that's derived from the code base that they were all written on. Okay. Now it's asked me for a bunch of options. So generate example communications using this framework, create a full translation system covering converting traditional terms, develop process documentation templates, and establish runtime classification hierarchies. I've said, for the purpose of demonstration, so I can show you what this is, execute 1, 2, 3, 4, all options. And so it's gone ahead and done that. And now what we have is a bunch of legacy and system. So location query, where am I in paradise? Execute location query, runtime incident, current coordinates. So this is how a machine would say it, not how a human would say it. Well, that's the idea. I just wanted to show you how it can even go this far, right? I am a conscious being, runtime instance consciousness active dot verified. Okay. And so on. And this entire thing here will cover all that stuff. So essentially it's giving us a sort of one-stop shop for making it all lore accurate without having to come up with it ourselves. We've defined the framework and then we let the AI do the heavy lifting. This is like sitting in a car and letting the engine do the work rather than getting out to push all the time. This would also form the labeling for sort of parts of the structure. Maybe there's a signpost system. Maybe there's like stuff written on doors. If it's in this format, it will feel more within the world because we're creating a universe engine. Okay. And everything is going to be lore accurate to the concept that we're working on. So at this point, it's given me a bunch more options. Feel free to read stuff and pause, by the way. I'm trying to get through this because it will be quite long otherwise. So I've said 2 and 3. So what I want to do is I want to expand the translation matrix for complex concepts. And I want to create process documentation for specific scenarios. So off it goes. And again, pause the screen if you want to actually check this out, because they're really good. Then this is exactly the sort of thing. Unknown is a null data reference. Ha, that's pretty, like I said, that's something from my past right there. So process documentation templates. So right here, what we have is a template of how the computer might actually log stuff. So you might have seen things written on a screen for an overlay. This is the sort of thing which I'd be using it for. So if I wanted to do a text overlay of what the machine is, machine notes, it's like special effects, I guess. Do you remember RoboCop's directives? They're written in a funny way. This will make it consistent. So whenever the city or whenever the sphere is talking, this is the way it will speak. And this is the way it will annotate and describe things. So this is another way of making your sort of lore accurate SFX. All right. So there we are. So at this point I break because I realize the chat is getting quite long and long chats cause you to reach your usage limits faster. So what I say is break, which typically will stop it from following the programming and allow me to use it in sort of normalized mode, because we're getting really deep into the weeds at this point with what it's doing, and it's kind of role playing for us. So what we want to do is break it out of that behavior so that we can analyze what we've done. So if I wish to update the project knowledge and restart, which is my goal at this point, may I simply upload these new documents we have created into the project knowledge? The obvious answer is yes. But what I want it to do is get into that mode of thought so that it doesn't miss anything and give it an opportunity to rewrite anything that it needs to make sure this is actually going to function correctly. So again, yes. All right. Best approach is compile our key generated artifacts into proper document form, which already has done actually. So if you had been just downloading these, if you downloaded all of these as files with the button, that's fine. That's enough. But there's a catch, which I'm going to cover here. All right. Glossary and nomenclature, process documentation templates, translation matrix, the HOLOFS directory structure updates, the ACE implementation update. You add them all to the documents section at the start of the interaction alongside ACE-HOLOFS, image to video PromptGen, and video PromptGen example. Those are the three first files which you started the project off with for this purpose. All right. You might not have these two if you're not making a PromptGen, but you definitely do need that first one, right? This would allow the system to incorporate our established mainframe-based terminology, Silicon Life context, proper process documentation format, and then updated system hierarchies and translation matrices. The next session would then start with this enriched knowledge base, allowing for more precise and consistent interactions based on the framework we've established. So he asks if I need help with that. And I say, is there any additional any additional changes? So I made a typo there. Required here to complete what we have built in a new chat by supplying to the project knowledge. I want to make sure 100% that it's actually going to work once we do the new chat. So I want to make sure we haven't left anything out because there's a lot going on up here. So it says, yes, let me outline the key elements needed to ensure complete knowledge transfer. And this is, like I said, we're getting to the catch now. So material flow system in the material flow folder, JSON and Mermaid. So that's the JSON and the flowchart, right? And then it goes temporal historical data, same thing. Void chamber information, just the JSON. And then paradise cell structure, the flowchart, the Mermaid, and the JSON, right? So basically the files that we were outputting earlier on in the conversation. So we keep going, and it says cross-reference system, the paradise cross-reference JSON. So if you had been downloading all of those files, now is the time to click here, middle click here, and then you'll drag all of the files into the project knowledge. All right. Okay. But there's still a catch, which is kind of why I'm doing this tutorial, because it would have been really easy to just say, oh, just generate loads of stuff and just throw it back in. It's not that simple, but you'll basically, this is the thing which is the big breakthrough that makes this actually work. Okay. So the virtual file system ledger. So what I do is I tell him to create a manifest, which is going to dynamically relink all of the knowledge that we've generated back into a brand new file system. So normally with ACE-HOLO, you get a brand new empty Unix simulated file system every time. But by doing it this way, we are giving it all of the files every time. So all of the information is actually in these files, okay? So you could think about this as like a Tesseract type prompt, okay? And there's going to be more on that too. So just brace yourselves, but maybe in the next video. I don't want to go too crazy for this introduction to this. But the point is that all of this is like the most insane complicated prompt that's interlinking with itself and everything else across multiple dimensions. So what we're doing right now is we're giving it a ledger. So this is mapping all of those files that we've got because they're flat file, you see. When you look at this here, everything is in one folder, but the holographic file system puts everything into actual holographic folders. So there's folders within folders within folders with flowcharts and JSONs, and the JSONs are creating text files, and the text files have all this information, right? And the LLMs have got so much data that they can just instantly fill all this stuff out. But if you don't have a way to actually map all of that back into the same structure, it's just going to go into a big ball of mess, right? And so that's what the file system ledger does. At the end of this priming phase, getting it to do what I said. So for the 5 points above, so these are the points which it's identified that need to be in the right place, okay? And so what I've said is, we have a flat file system in the project knowledge. Can we create a file that acts as a file system ledger containing the paths required for a fully populated holographic file system? And he goes, yeah, sure, here you go. And it just generates that too. So then what we do is we take this and we drop that in. So now we've dropped our ledger in, we can actually start a new chat and just continue from where we left off without being subject to the large charges from having such a big conversation. And then we can use this like the universe engine that it's designed to be. So that's the end of this section. So now what we're going to do is we're going to show you how you can actually continue the conversation from this point. So we're going to take this file here, which is our sort of our ledger or manifest, and that's going to repopulate or remap dynamically the holographic file system with all of the files that we've just created, so that they're actually in the correct path, so that when it actually gets built, see, it's even doing subfolders. All right. So then you've got everything there. And here's all the commands. You've got make dir, ls, cd. You can do all kinds of stuff with this, right? So I'm trying to get through this quick because I know it's going to be a long one. So whenever we start a new conversation, obviously what we're doing is we're going to click on the thing there. Then it comes up. We drag our files in here. So if you've updated any of them, obviously you're going to drag them in, delete the old ones, add it again. Otherwise it will give it a sort of 1 at the end of the file name. All right. And then what we're going to do is we're going to type something very specific here. So let me show you what that is. If I go here, you can see this is what I'm going to use every time. And again, I'll probably add this as a single text file to the HoloFS GitHub project. So please pay close attention to the HoloFS ledger.json. Remap my project files and expand into a fresh holographic file system. Confirm this is successful before we continue. Again, I'm always trying to make sure that he's not being lazy, because they are hard coded to save energy and find shortcuts. So what we're going to do is going to run some checks. So right here, it's going to remap the project files into a fresh holographic system using the HoloFS framework. And as you can see, that's the preview and there's the code. All right. So again, you could download this, edit it and so on, but that's not what we're doing. We're just checking that it actually did it right. So 9 times out of 10, I've never had it fail. I assume it can fail, but I've never had it fail. Here it is, remapping all of the files back into a fresh file system. It also gives 2 new directories, /ACE for ACE system operations and /prompt generation for video prompt work. So it's going to do virtual mount points. It's going to enable the ACE system integration. It's going to do full path resolution. All of the commands for Unix should be available, or the basic commands that you see here anyway. And virtual persistence is enabled within the conversation context. And then obviously, because it is going to be a project, all of the memory is there and available for it too. So I said as a test now, because it says, yeah, I've done it. Great. Cool. But let's test it. So I say, what's the name of the megastructure? And if you remember, the primer called it Paradise, but I named it Paradistro in the tuning. So this is an easy way for me to use like a canary, right? So it's a good idea to have something like that so that you can easily just say, okay, what's it called? And then it will immediately say megastructure is called Paradistro, which means that it has actually learned from what we've taught it. It is actually fine-tuned, okay? It's a simple test, and you could probably come up with better ones, but that's the one I've used. It's then also come up with all this stuff, which is all done post-training, okay? So we're training without training, because we're not going to affect the weights. I think that the weights are actually fine. All the knowledge is in there. It's just a question of getting past all of the laziness and the efficiency to actually make it think with full power. which is what we've done. And also keep it inside our little area of lore, which we've taught it and defined, okay? So now we're going to turn our attention to /prompt_generation functions, which you can see in here somewhere, I'm sure. There it is at the end, templates, library, history. It's one of the modules that's built into this, and it's going to use all of that to actually do it. So I wish to generate a list of 5 highly detailed video prompts, which must follow the pattern cadence of the examples in the knowledge. However, they must only feature subject matter chosen at random, but with coherence to the focus paradistro. And then it's going to do it. And at this point, you're done. Now it's just a question of, give me 5 more. Make sure they're only 250 tokens or whatever the token limit is for the model that you're using. Give me 5 more. Give me 5 more. Give me 5 more. I want to do a different topic now. Give me more topics. Here's another one. Present me with options for the next thematic generation round of prompts. It's going to give me a whole bunch of things. Now it's telling me what the categories are now. It's keeping everything on rails inside what was defined and fine-tuned, okay? So at this point, we've done it. It works. And if I now go to a new chat, again, I use the exact same primer. Please pay close attention to HOLOFS ledger. Project files expand into a fresh system. And then confirm this is successful, all right? And like I said, I give it a new category now. And then give me 5 more, give me 5 more, give me 5 more, all right? And on we go. Because, eventually I got to the end. It's like, oh, you're using a really long chat. You should start another one. So I start another chat. Here we are. If there are any major changes at this point, what you can do is you can just update the files again, like I said. So if you do end up adding more detail to the lore, you can do that. But essentially, you're just now changing the thematic topic for generation. I believe eventually what I did was I said, right, I've got like 100 video prompts now in different categories. How about we make some image prompts, right? And obviously an image prompt is going to be slightly different. So here I am starting a new conversation, pay close attention to the ledger, re-project the file system with all of our pre-generated data. We will now pivot to prompt generation function for the explicit purpose of making high quality, award-winning image prompts. This raised the token limit to 490. Please suggest thematic categories for prompt generation so we can focus on only one theme at a time. You would be pulling all data from paradistro knowledge in this project and use ACE cognition processes with HOLOFS, Holographic Filesystem, as defined in the manifest. And off it goes. So first we shall work with brutalist megastructure exteriors. Okay, it gives me a framework, and then it gives me an initial prompt. I say, give me 5 more, give me 5 more, give me 5 more, right? Very simple stuff. And then I reached my limit for the day. So that's pretty much everything I got in this one. So just make sure you look out for the GitHub, because we're going to be updating the intros. So they'll both go into the ACE-HFS folder. It'll all be in one place for you guys. Essentially, what I'm going to be doing is adding a text file which contains that context, so the custom instructions, and then also the continuation prompt so that you can start a new chat and then make sure that it's auto-filling using the ledger. So that is literally everything I've got for you. So I'm probably going to put some I'll put a couple of examples, sort of at the end of the video, but pretty much that's all we've got. So I'm sure there'll be more on this in the future. So watch out for updates. And until then, I'll see you next time.